This is one of my 3 Walker Turner drill presses. They're all identical. A Jacobs 33 chuck, 1/2 inch maximum. This one and the other 2 have a production table. That means it's perfectly flat with an oil, or in my case, a trash groove around the perimeter of the table. When these things leave the factory, there's no holes in them. Later in their life of the table, they may acquire some holes or even some tapped holes. This drill press is a variable speed drive. This drive allows variable speed operation of the spindle. Anywhere from very slow. This, if you can see it, is a display reading hertz. Normally these are 60 hertz devices. This device converts the 60 cycle energy that's distributed on the grid to any frequency between 0 essentially there's 61 hertz, which means the motor's running a little faster than it was designed. And then I can take it up as high as 120 hertz. I don't like to overspeed this motor. It's only designed for a maximum of 60 hertz. I don't have a tachometer fitted to this machine. And I believe, looking at the serial number, this was made by Walker Turner somewhere in World War II, most likely 1943. It spent its whole life in a plant dedicated to repairing the radio engines that powered the DC-3 or the C-47 in military service. That plant was mothballed, and this drill press was being made surplus when the plant was totally decommissioned, I think in 1973 or 4. This table, though, is a late production Rockwell. It fits perfectly, which is only to be expected, because Kearney and Trecker bought Walker Turner and sold the presses under the Walker name. Then Rockwell bought Kearney and Trecker and Walker Turner, and then they sold the presses under the Rockwell machine tool name. I bought this table brand new at an auction. It was in a Rockwell box, and I replaced the original table on this machine. My other 2 drill presses are also Walker Turner, but from the serial numbers they appear to have been made while Kearney and Trecker was involved. Now those are 2 presses mounted on one production table with the oil groove or trash groove the whole way around the perimeter of the table. In between the 2 drill presses, or the 2 drill press setups, is a storage cabinet, and on the surface of the storage cabinet are a number of drill indexes: fractional, decimal. I'm not sure there's any numbered sets there. And in the cabinet, under the dual head setup, are drawers containing all kinds of drills, reams, a tapping head that I used on the dual drill press setup for production work. Now on the table between the drill press setups I have these 2 metal blocks, and they're made, or at least marked, Greenfield tap and die. A bunch of miscellaneous bits, transfer punches, large silver and Deming bits, more transfer punches, and some cap screw reamers. But these metal holders lately have really become a sickness with me, or an addiction, or an affliction, depending on what term you want to use. And so I have begun to order these white metal cast drill sets, drill holders, from Cleveland. That is, they were made by Cleveland originally. And this one, which is a more ornate, in that it has all kinds of little filigree and stuff on it. You can see it was made by Cleveland. It has the fractional drill size and the decimal drill size. I have a hunch this one might be older than the other two, but I'm not sure. This is another fractional Cleveland. The third one is a number drill set. So this holds 60 drills, 0 through 60, while the fractional set holder holds 29 drills each. The problem I have on these two, and maybe this one, I haven't tried it, is I can't get drills in all the holes. They're clogged up. And although I think I have drills in all the holes of this one, see, they're not staggered nicely. That's probably because there's debris or corrosion in these holes. And so I'm going to have to take each drill, invert it, and ream out its own hole. Well, that's over 100 holes, and at least 90 different bits, because I can use the fractional bits for this one and this one. So I have to change almost 100 bits, each one a different size. And so I purchased a keyless drill chuck. You can see it's a 1/32 to ½ inch keyless drill chuck. And for some reason, I don't know why, it has a part number. And the last two numbers are 33. And it cost $28. It cost $17 to purchase and $11 to ship, from a guy by the name of Carbide B_36. Now these drill chucks are Jacobs number 33 taper, which means they're merely held in with a tapered male and female socket. This drill has a knurled collar that allows me to come up against the chuck. You see it's screwed down against the chuck. Then using a hook wrench, using a pin wrench, sometimes it can remove the drill chuck. Sometimes. There we go. Now, this is a pin wrench. You see, it has a one size fits all, and it has a pin in here, as opposed to a hook wrench, which has a hook on the end. The difference is one fits in a set of holes, or a hole, and the other fits into a crosscut. Now, I've never removed this chuck before, and I see that it's got some, I don't know, maybe Loctite on it. Must not have been a very good Loctite because it was fairly easy to remove. If your drill press, or if you're trying to remove some other Jacobs 33 device, they make a set of these wedges that fit together like this, and they're tapered, and you're not supposed to pound on them. You're supposed to either put them on a vise or maybe use a pair of channel locks to push them together. In any event, that'll wedge the two halves of the 33 taper apart, and you can remove the chuck. To put this chuck on, it's merely there. It's on. I use this drill press for everything, so laying on the floor and on the table are lots of nice, well-used pieces of wood. A bench vise block, it's hardened ground. I'll loosen up the quill and just now, when I did that, I had the jaws retracted fully inside the chuck. I don't want to pound on the jaws. See the jaws coming out there? I had them fully retracted. This is the number 60 drill, and my eyes aren't too good, but I felt it bottom out. And that feels good. So I'll just do that. Piece of 6-inch steel pipe, piece of scrap wood. Now when you're moving your drill press head up, don't try to do it manually. Don't grab a hold of it and loosen the stop. Grab a hold of the quill. Raise the head and lock the quill. Then lock the head to the tube. Then go ahead and unlock the quill. And see, you've moved the head up without the danger of it falling down. I just completed reaming or cleaning all the holes, and it looks like the number 2 drill in the Chinese drill set is really number 1. I have a mic out here, but I was using it exclusively on the smaller drills. I was trusting the stamping on the shanks of the bigger drills to be accurate. But the number 2 and the number 1 mic exactly the same. This is the kind of debris I took out of every hole. I guess this thing was used in a dusty, someplace with some airborne dust. And maybe when a hole was empty, it collected that. But every hole had this kind of debris in it. So here's the completed index. It's missing some drills that I just don't seem to be able to satisfy myself by miking them that they're what they're supposed to be. And I'm not putting in the unserviceable number 2 drill. So now I just need to do the fractional drills, and I'll be ready to drill some actual holes. The number drills in the Cleveland holder came from this fellow here, J Quality Tools 2011, and it costs $25, free shipping, and delivery was pretty quick. But the number 2 drill was really a number 1 drill mismarked, and I have questions about 3 of the smaller drills in like 46, 47, 48. Now the fractional drills cost $35, and they're supposed to be cobalt or high-speed steel containing cobalt, and they came from NIUM LUCME. I'll let you figure that out.